In this video, we will look at the maximum height of a ball. This is an application of a quadratic equation, and it's a pretty important type of example to be able to interpret and answer. So if a baseball is projected upward from the ground level with an initial velocity of 64 feet per second, then its height is a function of time given by s equals negative 16t squared plus 64t. Now, not really very practical because a ball isn't going to usually be projected from a height of 0, but here's what it would look like. So it's shooting up from the ground. And from the ground, maybe there's a groundhog, right, throwing the ball. And it's going to reach its height and then hit the ground again. But let me put in here an XY axis so you can see this. This 0, 0 is ground zero. This is when the ball is launched. And what we're looking for at this point is, so here's the t, the time, and here's the height. But what is the time elapsed before it hits the ground again? Or in this case, find the height, the maximum height that the ball reaches. Do you see that as a parabola? That this maximum is represented by the vertex. So really a fancy way of saying what this question is asking would be to say find the y value of the vertex. Find the y value of the vertex. Now I'm going to rewrite this as a function form. So we have s of t equals negative 16 t squared plus 64t. And if I wanted to find the vertex, I have a handy vertex formula. I could use this formula to find the t value of the vertex. So remember that the vertex is going to be an ordered pair. In this case, t comma s, or keeping with the function format, s of t. So t is going to be found with this formula, the opposite of b over 2a, and you might be looking at thinking, do I need to memorize another formula? Well, probably not, because probably you know this formula. Opposite of b plus or minus the square root of b squared minus 4ac all over 2a. That's just the quadratic formula, and if we get rid of the radical, we're left with this easy part of the formula, the opposite of b over 2a. And in our example, a is negative 16, b is 64. A is always the coefficient of the squared term. B is always the coefficient of the linear term, the t in this example. So we'd have the opposite of b all over 2 times a. Now I'm going to do these problems by starting with an empty parenthesis, and then I'll fill in the b. B is 64. Fill in the a. A is negative 16. And if I find this value, if I simplify this expression, you could pop it into a calculator, or this one you could do mentally, because I could just start reducing, right? The negative over negative, those reduce. 2 goes into 64 evenly. 16 goes into 32 evenly, or use a calculator if you're more comfortable doing that. But it looks like this is going to happen. The height, the maximum height is going to happen when t is 2. But it's not asking us when, how long after it's thrown does it hit its maximum height. It's saying what is the maximum height. So all I need to do now is go back to our function s of t equals negative 16 t squared plus 64t, and I'm going to replace the t with 2. Replace the t in each place with 2. So So S of 2. Why 2? Because that's the first part of our vertex coordinate. And if I plug this into a calculator, I'm going to get S of 2 is equal to 64. So it looks like our vertex is T equals 2, height equals 64. And to answer our question, what's the maximum height? Max height is 64. 64 what? Looks like this was measured in feet. The highest that the ball gets is 64 feet. Well, I hope that this short video has made this problem a little bit easier for you. Reach out to me if you have further questions or try some other examples like it.